tons to choose from, but I'm not sure I had all that. Yeah, so thank you very much again. I'm going to talk today. It's a slightly different presentation, but I wanted to make sure I touched on the same topics and questions that we discussed at the Native Plant Society meeting about a month ago. So in my role as a restoration ecologist with the Center for Natural Lands Management, I'm really working with a wide suite of practitioners and experts, ranging from other fire scientists to butterfly biologists to other wildlife biologists to, folks studying the Mazama pocket gophers. We have a lot of different areas of expertise and a lot of interest in recovering this ecosystem. And so just to get a quick show of hands before I jump in, who is familiar with the South Puget Sound Prairies? Okay, most of the group. And so I'm assuming by familiar that means you've been there or you've seen some of the species, you know about the species. Great. I'm going to give a little bit of a background for those of you that aren't familiar with the ecosystem. But yeah, this is a really unique system that we've been, over the last 20 years or so, making some really incredible strides in the recovery of rare species. Starting from Scotch broom, shrublands, and now having rare Taylor Checkerspots flying in a diverse native habitat. It's a pretty exciting development. So I'm going to talk today about the role of fire and how we are using fire to recover this system, and how we want to start thinking about fire as a potential restoration tool, especially for some of these fire-sensitive species such as butterflies. So our ecosystem restoration and kind of habitat maintenance that we do out in the South Sound Prairies is a pretty complex process. This actually suggests that it may be linear. It's not necessarily linear. There's a lot of feedbacks and a lot of circles here probably in this process. But really, we typically start with a fairly degraded site that may or may not have native species present. Here, this is the patch of tall oakgrass, which we see in a lot of kind of abandoned agricultural lands. It also could be monoculture of Scotch broom. Anymore, we see these as excellent challenges and great opportunities instead of like a lost cause. So really starting with this degraded site, we go through several different steps to reach our ultimate goal of having this kind of functioning system with a diverse native community. This involves several different stages, even within each of these boxes here, with site preparation. I'm going to go into each of these very briefly and just talk about the different tools that we use. But site preparation, just to basically clear the site if it needs to be in terms of removing non-native species, establishing native communities, and then finally reintroducing rare species to that site once the habitat is sufficient to support them. And so really we're thinking about not just a single species or one structure in particular. Our ultimate kind of goal for each site will depend on the site history. It'll depend on its geographic location within the larger context of the prairies. It'll depend on what we think that site can really support. And so it involves a complex set of tools to restore the complex trophic structure that we're aiming for here. So the prairies that we're working in, and many of you probably know most of this, but really they were formed, the prairies in the Willamette Valley, Puget Trough, Georgia Basin ecoregion, here outlined in red. I'll call it the WPG for short, a little less of a mouthful. Formed by retreating glaciers during the last glacial retreat about 10,000 years ago. We're here, see, Olympia's right here, smack in the middle. It's understood that these prairies were maintained by anthropogenic burning for several thousand years, with an FRI here as fire return interval. The amount of time between fires is estimated to be approximately 3 to 5 years for any given place in the landscape. The prairies have gravelly, well-drained, very low nutrient soils. And most of these, I should say, the gravelly, well-drained, low nutrient soils are typically the prairies, the upland prairies that are preserved, that have some native component. A lot of the other remnant prairies that are now rangelands or croplands have much nicer, deeper soil that were probably, initially identified with Euro-American settlers as excellent land for growing things, and including cattle. So most of these deeper soil prairies have been converted to agriculture, and we're getting, over the last couple of years, we're really starting and pursuing now to investigate the opportunities that might exist in utilizing these agricultural and rangelands for conservation. Do you have a question?
You mentioned that this was formed by the retreating glaciers. I was discussing a little bit of the fire by the Indians as something that might have continued from a natural burning during the hypsothermal, maybe 5,000 years ago, a time that was drier and hotter, I think. Mm-hmm. Do you know where the hypsothermal fits into the equation at all, or have any thoughts about that?
In terms of there being kind of a natural
maybe
fire
natural
ignition.
Fires that
Yeah.
might have preceded the anthropogenic fires.
Yes. Yeah, I know. Good job. That's I know. Certainly in the Midwest, U.S. and the tall grass and even the short grass prairies, that is perceived to be the history of those sites. So there's a combination of anthropogenic and natural fire cycles there with lightning strikes. I don't know. Certainly with the hotter, drier period, it's much more likely that what fires would carry, just in terms of there being consistent ignition sources, would be the issue. Like if there were more lightning strikes, then yes, absolutely. I don't know. I haven't heard much about that in particular, that being a driving force during 5,000 years ago or so. But I would imagine if there was, it absolutely could have been a combination of natural and anthropogenically maintained. Yeah. Or ignited. So I absolutely would support that. Yeah.
Have you looked at the data that they've gotten from the camas distributions? It turns out the camas throughout the western United States, all the haplotypes are all messed up because people kept dragging them around. And I don't know how much, other than the initial discovery that this was so, I hadn't seen any correlations with, say, for instance, camas in the Salish Trough, the Willamette Valley, and to see how they relate to this pattern of haplotype heterogeneity.
So you're just asking if...
Have you looked at camas in particular as being a plant that the Indians were burning for?
Oh, yes. We haven't studied that, but that's been one of our primary, something we've understood as one of the primary crops for the prairies that was harvested was camas. So yes, absolutely. And I'm sure it was moved around. It would make sense. But yes, and that's one of the major disturbances that these prairies currently do not have, is digging for camas bulbs. That likely was a major disturbance factor over the last 10,000 years that we no longer have. So yes, I believe they were one of the primary food plants for the native tribes here. Was that the main question?
Yeah, I just wondered if you looked at the data, comparing haplotypes in the Salish Trough with the distribution of haplotypes of camas throughout the West, and see maybe if you could find even the tribal relationships that might be indicated there.
Right, no, that's a great idea. Something I'm not familiar with, but yeah.
Wasn't it also true that the camas bulbs made it all the way to the Sioux east? When we were there, they were talking about camas bulbs that they traded from the Northwest.
Yeah.
And so the Indians
I'm
said
surprised, yeah.
it was a major crop for the Indians
Right.
to have the camas.
Right, yeah. You can see it's evident today when you go out to the prairie and see, just everywhere. Basically, one way to identify remnant prairie is to see if camas present.
Right.
So, yeah, that's absolutely one of the major crops of the last 5,000 to 10,000 years on these sites is camas.
And by the way, they're delicious to eat.
Oh yeah, you get it roasted, right? Did you actually cook them?
Saute them in butter.
Okay, great.
They're so good.
So now, a lot of these prairies, because they've been largely converted, there are a range of threats I'm going to discuss here in a minute. They host several rare, threatened, and endangered species. And so a lot of our restoration work is geared towards recovering some of these species onto these landscapes. So the threats to the prairies here, there are many, but the primary ones are this altered fire regime. You know, I mentioned the fires we understand to have been about every 3 to 5 years. The natives were pretty regularly burning these sites to keep them open, to basically manage the crops on the landscape. And over the last 150 years or so, these prairies have seen basically little to no fire, leading to an encroachment of non-natives, largely Scotch broom and other shrubs, and also conifers, so kind of a native invader of Douglas fir onto the prairies. And then also, one of the biggest threats to the prairies is the habitat fragmentation. As I'm sure you all know, prairies are very easily paved over or colonized. It doesn't take nearly as much work as it would to cut down a forest. So a lot of towns, a lot of developments have taken place throughout the Puget Sound on these remnant prairies. And so what we have left is a patchwork of what used to be, which obviously makes a big difference for some of the species that we're trying to recover in terms of having connections between the different landscapes, corridors. So that's one of the strategies we're trying to utilize, is actually connecting little pockets of habitat throughout the Puget Sound to make it so the species have a little bit more land to work with. So I mentioned the restoration process a minute ago, and just to give you some examples of what we do in each of those stages. The first stage in the restoration process is this invasive species removal, and we have several different strategies that we use to do this, depending on the type of the invasive species, depending on the site history, depending on the policies that are implemented and are in place for a certain site. We do use prescribed fire to remove several species, especially things like Scotch broom. Mowing can set things back by a year or more, but just keeping things from going to seed. We do use herbicide to remove non-native species, both grasses and forbs and shrubs. And then hand pulling, which is extremely effective for things like Scotch broom, but as you can imagine, it has to be done in very small patches at a time. However, over the last 20 years, the hand pulling has been quite effective at glacial heritage, at removing by 20 years of a couple days a week of 10 plus people pulling Scotch broom. It's gotten there. So in addition to these other treatments, but it's a very labor intensive method, obviously. Yeah.
Do you ever use light barriers?
We on a large scale, no. There's been some experimentation, but not as a large treatment. So you think shade cloth and things? Is that what you're talking about?
Well, my favorite is plywood if it's available.
Oh.
But you can use cardboard, and there are other ways to block the light.
Yeah.
Then if you don't want soil disturbance or if you don't want herbicides, it avoids soil disturbance and it avoids herbicides. And if you want to use them also for a shelter for things like reptiles, amphibians, beetles, and spiders, they can double as that.
Yeah, I think if there are small areas that you're interested in restoring, that could be very effective. The challenge when we're looking at hundreds to thousands of acres, we have that challenge of trying to manage kind of cost-effective strategies and labor strategies that work, in terms of the time and money that's available. But for certain areas that may be important for some of those species or types of organisms you mentioned, that might be an option. So, once we have removed the invasive species from a site, or we've removed the target species that we are trying to get rid of, often there's a couple of loops here in this process. Usually when you remove one invasive species, you open the door to another. So that's been our learning is, once we get rid of the Scotch broom, we have invasive grasses. Once we get rid of invasive grasses, we have invasive forbs. And so learning the different strategies to get rid of those has really been a challenge, but an important one. And so once we are able to get rid of the nastiest invaders, we're able to start preparing the site using prescribed fire again to clear some of the thatch and the moss that has built up over about 100 years, to Also, just provide some nutrient flush to the species that we then seed in. We also have been experimenting with some soil amendments and mycorrhizal inoculation to affect and I won't go into too much detail here, I'm happy to talk about this more later, but to really influence the nutrient availability at the site and to potentially provide kind of a leg up to the native species that we are planting and seeding out onto the prairie to give it its mycorrhizal fungal inoculum to help the plants access more nutrients and water when we put them into these harsh prairie conditions. And then the final stage, that's not actually number 1 again. The final stage, number 3, is this native habitat enhancement. And this is where after we've removed some non-native species, after we've prepared the site for planting, we can then put in our native seeds, our native plants that we grow at our greenhouses, and then ultimately reintroduce or translocate the rare species into these functioning habitats and diverse habitats. So as you can see, prescribed fire comes into play a couple times in this process, playing potentially very different roles in restoring a site and maintaining the habitat at that site. And as we talked just briefly about already, fire has played a multitude of roles and does continue to play a wide variety of roles in early successional systems, which prairies are one of them. It can remove the litter and moss, as I mentioned, expose soil for seed germination, prohibit the invasion of shrubs, so it actually kills off the seedlings so the shrubs and trees are not invading into the prairie. And it can provide a flush of nutrients for some of the species that we then plant or seed in, or recovering perennials that are there on site that have their roots below ground. And some fairly recent, in the last 10 years, research has looked into some chemicals called butanolides, a class of chemicals that are found in ash and smoke. And these chemicals have been found to trigger germination of several prairie species and grassland species. And there's been some research done. Carl Elliott, who's in the process of publishing his master's thesis here at Evergreen, he has looked at butanolides and their impact on the germination of native prairie species and some of the non-natives. And he's found that several of them had much higher, significantly higher germination rates when exposed to these compounds. So if you think about it, it makes sense if the fires are happening in the fall, and then the rains come, they wash this ash and these chemicals into the soil where those seeds are sitting in the seed bank, it can actually stimulate germination. So there are quite a few different roles that fire plays that are not occurring with several other management activities. You know, so the germination of trigger, this flush of nutrients, some of these things cannot or aren't taking place when you mow or herbicide, for instance.
You mentioned getting rid of mosses. Why do you want to get rid of the mosses?
We don't want to get rid of all the mosses, but there's a very strong negative relationship between germination of several of our species and moss cover. If you go out to the prairies, especially prairies that haven't burned in decades, sometimes there's 2 to 3 inches of thick moss, right? And I have nothing against moss, but when it's covering like 100% of the ground, it makes it very difficult for the native species to get established. So ideally, we'll have kind of a heterogeneous patchwork of moss and lichen, and a little bit more of a diverse community of mosses and lichen that are present on the site. That there are actually, we were just learning, there are some more, I don't want to say fire adapted, but there's a different community of mosses and cryptobiotic crusts that are present on the site after burning that only exist in burned areas that may play an important role in terms of providing nutrients and stabilizing soil, things like that. So we want to ideally diversify the moss community a little bit more than the few species that are there if it hasn't burned for a long time, and provide more of that patchwork. Does that answer your question?
Kind of. I'm finding mosses are, I think, much more critical in our forest areas for forest species than most realize. Yep. And so I'm finding that it's looking like a good moss cover of certain species is critical to a lot of things recovering.
Yeah, and that may be true for the prairies as well. It's just a matter of who and where. So
Sure.
that's what we're starting to learn about now. Yep. All right, so considering some of these benefits that fire provides in this ecosystem, we have been increasing the use of fire over the last, right about 10 years, 9 to 10 years. Starting in 2005, there were only about 2 to 3 burns back in 2005. And now, and when I say we, I mean the South Puget Sound program, which is a large collaborative group of partners, state, federal, nonprofit, private organizations and agencies working together. And now we are up to, let's see, if we look here, the number of burns is in the gray, between 40 and 50 burns per year in the prairies, and this is in the South Sound prairies, including those on Joint Base Lewis McChord, where a majority of the burning takes place on the prairies. And the number of burns has increased from about 2 burns, the acreage has increased, which is in the black, from about less than 100 acres, and it really varies by year recently, largely due to weather and politics, up to about 3,000 acres last year, or in 2012. So this increase in the amount of area burned has been paired with an increase in the amount of firefighters. Naturally, in order to do this, we need more people to do it. And those people are getting more and more trained in kind of more strategic and kind of more sophisticated application methods. And so we've been learning more and more about how to use fire so we can actually be a little bit more strategic in its application. Yeah?
Are these firefighters actually associated with your program, or are they?
Yes.
So it's within the program.
Well, the program, like I said, which is the collaborative program of all the partners.
They have to be certified, right?
Yes.
Yeah.
And so when I say firefighter, this requires a minimum of a 40-hour training plus some field training, pack tests, so that you are, shown you're fit, you are capable, and you are very well trained and knowledgeable about the ins and outs of actually burning. And then from there, that's kind of the minimum. And then we have several different, and I didn't bring this, but several members of the team that are much more advanced in their training, all the way up to burn bosses that have to have, it's like a minimum of 10 years of experience and lots of trainings to get there.
So do you use just the local fire districts and so on?
Well, we use all of our own equipment and gear and engines, and we don't have the big red fire engines like you imagine driving down the street, but we have trucks that are outfitted with pumps and 500-gallon tanks, and so that's equipment and supplies that we've acquired over the last few years. Yeah. All right, so with this training, we have slowly gained a much better understanding of how we can use fire on this landscape. It's not just laying down a row of flames and walking away. It never was. Or maybe it was probably a couple hundred years ago. But now with the fragmented landscape that we have, there are many more challenges, certainly, in applying fire when you have a row of houses over here and a school over here and a highway over here that we don't want to get smoke anywhere there. There have to be a lot of considerations on how fire can be applied to avoid any major damages or impacts to the surrounding communities. So speaking of surrounding communities, not necessarily thinking of human communities, but here of the butterfly communities. A big question that has come up, and a valid one, is about the role of fire on these butterfly communities, the impact of fire. We have several native, obviously, prairie butterflies that I'm sure you all are well aware of. And quickly, actually, I want to pass these around. Maybe I'll do it at the end. We have a recent publication or just production of the butterflies of the South Puget Sound. So I want to make sure folks have a chance to look at this. And I can send you a link or a PDF of this if you're interested. So I'll pass these around a little bit later.
Is this the one that Ann and Rod put
Yep,
together?
Ann and Rod. And I think several of you in the room also contributed to
Right.
that. So maybe you're even more aware of it than I am. So the species that we're working on here in the South Sound, these are just a few. Now a lot of our energy is focused on the Taylor Checkerspot and the habitat needs for that butterfly with its recent listing as federally endangered. But when we think about fire effects on butterflies, there's a couple key points that we need to think about. One being that not all fire is equal. It's really important for us as fire practitioners and as ecologists and as butterfly enthusiasts to remember that it's important that we tailor our fire application to specific ecological objectives. And those objectives may be just basic restoration, where we are removing Scotch broom, where we want a really hot fire to remove Scotch broom, and there are very little to no native species in that Scotch broom shrubland that we're concerned about. If we have a fairly native dominant or fairly diverse native prairie that may have some of these species present, we're working more on habitat maintenance, and we might not want the same type of fire to go through that area. And so I'm going to talk a little bit more about this next. And then the second thing to think about is that we have seen that without active prairie management and without fire, we quickly see butterfly habitat decline to the place that it's no longer in the realm of use for the butterflies, that they're no longer providing the resources necessary for the butterflies. And that we've seen it only takes a couple of years for that to happen, 2 to 3 years. And so this is a big concern for us as we are expanding, especially expanding our captive rearing and translocating and reintroduction of the Taylor Checkerspot butterfly. We need to have those tools to maintain the habitat once that butterfly is there. And spraying and mowing may not be the only ways to do this. Yeah.
Is it true, it was a few years ago, that the healthiest population of Taylor's Checkerspot is actually in the artillery impact areas?
Thank you. I can skip one of my future slides. That's great.
And I'm wondering if you guys have studied the effects of all those explosions and everything and what it's doing as far, obviously it's burning.
Yeah.
And so maybe that is something to be mimicked somehow.
Absolutely. So a couple of points on that. The artillery impact area, the range 76 it's called on base, is the largest population, reaching up to 10,000 individuals or more, of Taylor's Checkerspot butterfly. This is actually the source population for the reintroductions. So animals are taken from that population, captive reared, and then reintroduced elsewhere. Spoken to a couple different biologists on base this past week and ecologists about the fire return interval there. So how long between fires, like how many years is it typically between fires? And they all came back with 1. Sometimes it burns twice a year. However, if you think about it, it's been burning there for decades. There was never a very large interruption, as far as we know and understand, with the Nisqually use of those lands, Nisqually tribe use, and then the conversion to the army base, military base. So there's been pretty continuous fire there for decades. And basically because of that, there's very little fuel. We don't have large Scotch broom patches. There's no big, thick thatch layer. Not a lot of moss. There is moss, but it's not anything like we see out on the other prairies. And so the fire, when it starts in those systems, it burns very slow and it creeps, and it doesn't burn a lot of it. There's a lot of unburned patches. And then when the next fire comes through the following year, or even later that year, same year, it'll burn those unburned patches and leave the other ones alone. So it's kind of this very heterogeneous, patchy system with a very high diversity of natives and a lot of open bare ground that provide excellent habitat for the Taylor Checkerspot. Yeah.
I had a friend of me report that he was in the middle of one of these burns and almost didn't notice it.
Yes, you can basically step over the flames.
Right.
I mean, if not noticing it, that might be a little scary. If you're out in the artillery impact area, you should
Well,
probably
he was looking for it, but he didn't realize he was well into it by the time.
Oh, really?
Yeah.
Wow. Yeah, so that speaks to the low intensity of these fires and why they're low intensity, because it's burning very regularly. Yeah. So again, not all fire is equal. That's a great example of how, a fire like this, which was at West Rocky Prairie 3 years ago, a prescribed burn. That's me standing there. It was very warm. This is a patch of Scotch broom. It was probably 4 to 6 feet tall in some areas, and there were some natives there, but not many. And basically, the plan was to burn and herbicide and seed in more natives there to develop, kind of establish, get a native community established, a native prairie community established. And so this burn, the goal was really to kill this Scotch broom, right? This burn out at Tenalquock Prairie, which is in one of the areas that is slated for reintroduction for Taylor's Checkerspot. This was conducted this past year. You can see the fuels are very different. Here, this is also a fire. The flames are moving with the wind, but it's moving at, you know, a foot a second, or even less than, probably quite a bit less than that, probably a foot every few seconds. And so, versus this that's moving, you know, probably 10 feet a second. And so here our goals were really to increase the bare ground and stimulate those native seeds that are in the seed bank, stimulate germination, provide opportunity and space for those seeds to grow. So very different ecological objectives, therefore very different types of fire that we are applying. Yeah?
You've got the Scots broom here, a nitrogen fixer. Do you find when you're trying to restore places that have had Scots broom fixing the nitrogen that the soil's a little richer in nitrogen than's good for your poor soil adapted species?
Yeah, there's been a lot of research looking at the effects of Scotch broom on soil nitrogen, and there's a couple different competing. I've seen one study that said that yes, you see higher nitrogen in, well, a couple of studies that have seen higher nitrogen in areas previously invaded by Scotch broom. Another study looked at, they basically set up transects from like the heart of a Scotch broom patch going out into the open prairie. As it got thinner, you know, the Scotch broom got less and less dense. And they found total nitrogen did not change. So there's different forms of nitrogen that may be present. And they didn't specifically look at available nitrogen. I won't go into the details there, but they proposed that in those areas that did not have nitrogen, there may have been some of this crust. It's a nitrogen-fixing crust, microbial crust on the surface that actually fixes nitrogen. Cyanobacterial crust can fix large amounts of nitrogen that could be kind of making up for the fact that there were no nitrogen fixers bringing that into the soil.
I would think that the soil enriched by the nitrogen would give a competitive advantage to the weeds.
Yes, and that's probably what we're seeing. So soil, if the nitrogen that is fixed by the Scotch broom is hanging around in that system, because we get so much rain here, a lot of the nitrate is very labile. It moves very easily, is washed away basically within 1 year, and so you might not have a long-term nitrogen enrichment, but that following season, absolutely. And so I think there could be that short-term nitrogen pulse that allows for those non-natives to get established.
But you're monitoring the first year after burn heavily anyway, right?
Oh, sure, yeah. Yeah, multiple years.
Wouldn't your introduction of your lupin modify that and bring that back again, and then you'll get the Puget Blue?
Right, yeah, there you go. So yeah, there
no,
are...
No lose situation there.
Yeah, there's a lot of native nitrogen fixers as well, and other smaller non-native nitrogen fixers. So they're out there. And yeah, we are restoring lupin, so it's playing the same role, just at probably a much smaller scale. Okay, so in order to reach these ecological objectives, some that are more, restoration versus higher quality habitat maintenance, we really have to think about the fire regime. And so the fire regime has several different parts to it. I'm going to talk briefly about each of these, just different components that we really need to think about when we're discussing fire effects on invertebrates, fire effects on any part of an ecosystem. It's really important to understand what the season of fire is, what the severity, what the intensity, frequency, and extent. And again, I'll go into the definitions here in a moment. One challenge that I've had in reading through the literature when we're looking at fire effects on invertebrates is that often most of these are not presented, so it's hard to evaluate what type of fire it was. And if there may have been another type of fire applied at a different time of year or a lower intensity or severity that could have had a different impact on the butterfly or the invertebrate population. So one thing that I'm hoping to see more of is some of these components presented, so there's a better understanding of how fire is what type of fire is being utilized or being applied. Did you have another question? No? Oh, okay. Saw it again. So again, setting complex goals beyond just killing Scotch broom. It really requires some complex application techniques. Okay, so this might be a little bit hard to see. All this graphic is showing is the main historical fire season for 7 different areas in the U.S. or in North America. That is in red. So based on written documentation, based on research on tree cores, things like that, or tree rings, we know that, for instance, in Fairbanks, Alaska, the main historical fire season was between June and September. However, the prescribed burning that's taking place now, for political reasons, for air quality reasons, to avoid impacts on certain species, is in May and October. And also to avoid, potential wildfire escapes. And so you can see in some areas, the main historical fire season, it aligns well, especially in Alberta and in Athens, Ohio. But in other areas, they're opposite seasons. The times that prescribed burning is being applied are not the same as when they typically would have occurred naturally in those systems. Naturally being through anthropogenic ignitions or lightning ignitions in the past. So there's just something to think about, that a lot, when we're thinking about prescribed fire effects, season can make a huge difference. If we're applying fire in the spring, in the early spring, for instance, in Yosemite, to avoid air quality and escape risk, but the standard burning time of the year would be in the fall, you're going to have dramatically different impacts on the ecosystem. There's a lot happening in the spring that isn't happening in the fall, and vice versa. So that's something really to think hard about as we are thinking about fire effects. Yeah?
What are we seeing in the blue lines there?
Oh, I'm sorry. Yeah, so the blue lines, here, the blue line, I believe, is the temperature.
Oh, okay.
And, no, I had that backwards. I think that's right. And the bars here are precipitation.
Oh, okay.
So this is just, I think it's called a climograph. It's basically showing how, for the seasons, you can see the temperature gets hotter in the summer, and then drier, or cooler in the winter, and then the precipitation, in this case, actually is greater in the summer, and then it's dry in winter. Whereas you look at Yosemite, precipitation all comes in the winter months. This is January, February, March, April. And then it's really dry in the summer and really hot as well. Does that make sense? Yeah.
Well, isn't it also true that the main historical fire seasons may not actually replicate the best intended results for screw burn? I mean,
sure.
They just got fired because it was hot, it was in the middle of summer, didn't have any precipitation. And
Right.
that might not be the best opportunity either.
Right, it depends on what the goals are.
Right.
Yeah, and for a lot of these areas, I mean, these prescribed burns are done outside of that natural historical fire window because it's surrounded by housing developments, and it's just way too risky to conduct a prescribed fire. But, using fire in that system to at least remove some of the understory fuels, if it's in a forested system in, the west slope of the Sierras in California, you want to be careful to decrease the risk of a wildfire coming through there. So they'll do a prescribed burn in the spring when it can still remove some of those fuels, but it doesn't have a very high risk of escape into a wildfire. So it's kind of protecting those housing communities. Well, maybe it's not as good for the ecosystem, but the objective of that burn is to reduce the fuel loading.
There actually is an overall benefit from that program in the long run, because in the short term
Right.
you have impacts, but you can overcome those if you overcome the wildfire going crazy.
Right. And so a lot of these are, a lot of the issues here are dealing with reducing fuel loading in forests that have not burned for 150 years. So the fires that we are conducting in Western Washington, just to give you an idea of how they align with Taylor's Checkerspot, for instance, and probably several other invertebrate life cycles here. I'm not going to walk through the whole life cycle. I'm sure you're somewhat familiar with it, but basically the species is in diapause for most of the winter, or basically it depends on when you determine winter to end here. Sometimes it feels like it's June, but until about February, and then we have the post-diapause larvae. The pupa adult is flying in April and May, Depending on the year, sometimes it's a little bit more May to June. Then we have the eggs laid and hatching in June and July. And then again going into pre-diapause larvae, and then the diapause starts in late July, mid to late July, and lasts throughout the winter. And so our fire application really takes place during this, for the primary window of fire application for the western Washington prairies, South Sound prairies, is this late summer, early fall, from mid-July until, depending on the year, maybe creeping into October. And so these butterflies are hanging out in diapause, most of them likely below ground. Our understanding is that they diapause below ground 1 to 3 centimeters below ground. Potentially as an adaptive trait to fire, I'm not sure about that. So they're largely protected from some of those above ground disturbances that time of year. So I want to give you some data, and I'll try to limit the number of graphs here, but on information that we've collected on some of these prescribed burns in the prairies. So I mentioned several of the different components of the fire regime, just talked about season. Here we're looking at fire severity. So fire severity really is a measure of the amount of organic material that's left on a site after a burn. Or I should say the organic material that's removed by the burn. And so here on the x-axis there's different kind of, it's an index of fire severity that we measure the amount of organic material, the amount of ash that was left behind. There's a couple different metrics for determining if it was a scorched area or a moderate high severity. And so this is just showing the percent cover of these different fire severity categories, ranging from unburned, scorched, light severity, moderate, all the way up to heavy and high severity. And high severity really is where there's no organic material. It's burned off everything down to the bare mineral soil. There's white, fluffy ash. And the light severity, which we see most of, is really kind of a grazing where it's removing most of the organic material, most of the standing dead litter, but it's leaving a little bit of it's leaving the roots, it's leaving a lot of that moss. There's not a lot of ash. I mean, it leaves most of the surface structures intact. So here you can see these are 4 burns that occurred in 2011 at 4 different sites. And you can see basically that we had a pretty good distribution of these fire severities across the site. This is a picture of one of the pretty typical picture of one of the plots at one of these sites where it's very heterogeneous, extremely heterogeneous fire effects here, where even within a 1 by 1 meter area, you have some just scorched, some unburned. You can see that this is actually a hairy cat's ear, Hypotheris reticata, that stays nice and green through the burn, for better or worse. And this moss layer that is pretty well intact. And then areas that the moss is completely consumed and you're down to this blackened ash, this would probably be moderate severity, down to the soil. And so these 4 burns actually represent a pretty typical type of burn that you would have in kind of a habitat restoration, where we want some hotter temperatures, we want some light to moderate fire severities. So the temperatures that were reached in these burns, when we look at fire intensity, and this is something that we're starting to think more and more about in terms of the butterflies that are just below the surface. How hot is it getting on the surface? And how might this influence the butterflies that are in diapause? So we measured fire temperature here, and this is measured at the surface. We put these copper tags that have temperature-sensitive paints painted on them, ranging from, I think it was about 75 degrees Celsius at the low end, and each of these strips is a different color of paint that would melt when it reached a certain temperature, all the way up to about 900 degrees Celsius, pretty hot. And this shows, I think these, the copper tag on the left, this is a low intensity spot where it did not burn very hot. It only melted the paints on that first copper tag. Whereas if you look over here, this is a pretty high intensity. It burned up to probably I'm not counting through these, but probably about 700 degrees, 600 to 700 degrees. And so when we averaged that out and we looked across these 4 burns, We had 10 of these plots set up in each of the burns. You can see that the average at the surface, the temperatures range from about 400 degrees all the way up to about 650 degrees Celsius. That's very, very hot. Nothing will survive those temperatures at the surface. And here, this is placed above the moss. And so, depending on the relative humidity, depending on the depth of that moss, depending on how wet it is, that could either, the fire could burn through this moss and transmit the heat to the soil relatively easily. If it's fairly wet, that moss is going to be a huge insulating factor. And soil itself has a pretty amazing buffering and insulating capacity. So we had these on the surface of the moss, so the flames are actually moving right over these tags. And then here, this is also showing the canopy temperatures. This was about 1.5 meters above the ground where the tops of the grasses will be. So you can see temperatures were much lower there. This is kind of the tips of the flames. So ranging from 200 to 500 degrees or so. So we wanted to look beyond at the top of the moss, because that's not where we see these butterflies, not where they're going to be hanging out during the fire. So this past year, we actually got some data loggers and buried them at 2 centimeters below the surface. And this year we had some cooler burns. They were applied late in the season. And so the burns this past year we see were all in, we didn't have any that reached moderate or heavy severity. They were all in this unburned, scorched, and very light, in light severity. And so we buried these data loggers below ground, and in these burns we saw, this is showing the time on the x-axis. These data loggers are recording about every second, I think. And the temperature in degrees Celsius on the y-axis. And we had a control where it was set outside of the burned area, so you could see what it looked like, just the temperature that day. We had an above ground, so we placed one right on the surface, similar to where the others were. And we had a below ground, buried 2 centimeters. And so you can see the above ground has this spike when the fire goat went by. And this is for one of the sites, we only saw it spike up to about 55 degrees Celsius. It did not get very hot at this spot at all. And below ground, we actually saw it only went up to there was only about a 10-degree jump, 10 to 15-degree jump at 2 centimeters down, which suggests for these lower severity burns, there's very little impact to what could have been potentially a butterfly or something hanging out 2 centimeters below the surface. And again, this is when I came by and picked it up, so this is the heat of my hand, just so you know, that's that little blurb there. So that suggests that there may be some opportunity to utilize these lower severity burns to remove some of the fuels, to open up that surface a little bit, but also protect anything that might be 2 centimeters below ground. So the last two parts of the fire regime that I want to discuss is the fire frequency and extent. So fires typically that we apply as prescribed burns, we are rarely burning more than 25 to 30% of the entire site. It's usually much less than that in a given year. And so we never want to, for the plants, for the animals, for plants, butterflies, birds, mammals, we want there to be refugia around, not too far from the center of the unit for recolonization. And so that's considered when designing where the burns go and when they're applied. And as I mentioned before, in our burn team, we now have the capacity, just enough people and the skills, the training, to conduct some internal exclusions. So you can see in the picture here, this is a patch of kinnikinick that can be really important is a very important host and nectar species for the hoary elfin butterfly. And in some of our burns now, we will go through, kinnikinick burns very, very hot. It has a lot of resin. If it gets going, it'll burn to a very fine white ash, and it can take several years to recover. And so we will actually go in and wet it down around the kinnikinick and sometimes do what's called a backing burn. and so actually light around the kinnikinics, and so it burns around it. And so when the main fire comes through, it'll just drop down and it won't burn through the kinnikinic. And so we're starting to use some of those strategies to protect some resources on the interior of the burn unit, either before the burn or during the burn. And we can use different ignition methods actually to affect fire behavior, whether it's applying fire as a head fire, so it's moving quickly with the wind, or a backing fire, where it's moving very slowly against the wind. And if it's moving slowly, there's longer residence time. That heat is going to be in a particular place for a longer period of time. It can burn through more of that moss, burn down, and consume more of that standing litter. So that's another set of strategies we can use to affect fire behavior. And again, as I mentioned, we typically burn at a rotation of about 3 to 5 years. Yeah?
When you talk about the capacity and skills for these internal exclusions, that also include individual, like for instance, a person interested in a butterfly might have both food plant and nectar source resources that would be under consideration. Would they be included in this kind of exclusion?
They could be, yeah. So far we have not, besides kinnikinic, I don't know, maybe Peter, do you know of any other specific exclusions that we've done for butterfly resources? I think this is something that, so we are this year having I don't know if any of you know Mary Linders, I think she presented to this group a while ago. She is working with us to identify areas that might be good for exclusions. And actually, Cheryl Fimble, who has worked with us, she is with the Center for Natural Lands Management. She has worked with partners in the past on protecting the kinnikinic in the interior, but interior to the burns. We're just starting to think about other resources for other butterflies, other species that we might need to exclude. Yeah. But many of the native prairie species that are out there will bounce back just fine after a burn. So we're not as concerned just for the plants for excluding them necessarily, unless we've just seeded that spring or something. So there may be some specific exceptions to that. So I'll try to move quickly through this. For habitat maintenance for the butterflies in particular that we are concerned about, there are a couple primary components that we really want to see out there. Sufficient bare ground or open area for basking. We want low cover of non-native grasses and shrubs. They seem to avoid areas that are about over 20 or 30 centimeters high with vegetation, so we want to prioritize low-growing grasses and shrubs. And we have a high density of oviposition host plants and quite a diversity of nectar plant species. And what we've seen with our burns so far is that they're very effective at opening up bare ground, at removing that moss and litter. Here, this is those 4 burns again. You can see the pre-burn is in white and the post-burn is in black, and we saw really dramatic increases in the bare ground for the kind of moderate burns that I talked about first. These are those 4 burns that had the fairly higher temperatures. We also saw that they were fairly effective at getting rid of non-natives, at least initially. This is the first year post-burn. Second year post-burn, a lot of these numbers bounce back up. So even 2 to 3 years post-burn, we see those non-natives recovering pretty quickly. Another area of interest is looking at the fire effects on annuals. Peter Dunody has put together a paper looking at kind of the historical role of annuals in the South Sound Prairies. And we're seeing that the burns definitely lead to an increase in the annual species out there on the prairie. Unfortunately, a large portion of these annuals right now are non-native annuals. And so a lot of our seed and plant production now is geared towards annuals, native species, that we are putting back out on the prairies. And a lot of those annuals are really important nectar and some host species for the Taylor Checkerspot butterfly. So we really are trying to prioritize getting those species to fill this niche, to fill this annual niche that right now is taken by the non-natives. Yeah?
What's an example of a native annual?
All right. Thank you. I will pay you later. No. So there's a couple of native annuals here that we're really putting a lot of energy into growing at our native seed farms. Plectridis congesta, Collinsia parviflora, Lupinus bicolor, Clarkia amina. And I think, gosh, I don't know, do you know how many natives we're producing right now? Like the actual number of species? I feel like we're up,
About 30.
okay, I was gonna say 20 something, yeah. So around 30 native species, native annuals. So there's a lot of opportunity for expansion of this life history. The other thing that we are really focusing on, especially for the butterfly, is the host and nectar species. We're obviously very concerned. We don't want there to be any negative impact of fire on these species if we are then, a year or two later putting butterflies into the area. So we found that fire basically had no impact, either positive or negative, on the frequency, on the presence of these species. So this is looking at Cassowea hispida, harsh paintbrush, Viola, Lomatium utriculatum, spring gold, and Ranunculus occidentalis buttercup. And so we didn't see any change. The one thing that's not, these are the plants that were there pre-burn, looking to go back into those same units and seeing if they're there post-burn. We did not count, and I'm not showing you here species that we seeded in or planted in. So the burn provides this opportunity, right, for seeding in native species and planting. There's a lot of that soil exposed. So the species that we're seeding in and planting in, obviously the numbers are going way up. But these were some for the units we looked at that we actually did not see, that were there beforehand, and we could show that there was no effect, positive or negative. They were just hanging out. So to summarize the fire effects of these moderate severity fires on butterfly habitat, it does increase the bare ground, decreases non-native cover, increases our annual species, native and non-native, and we didn't see any negative impacts on some of our important butterfly species. So really our management recommendations here are to maintain butterfly habitat would be to focus our efforts once we've gotten through kind of those restoration burns to remove the non-natives, to remove the scotchroom, to conduct some patchy low severity burns that really aim at achieving those butterfly habitat objectives. If necessary, excluding some of those really important refugia. Here's another example. This was on Joint Base Lewis McChord, where they conducted a few exclusions where there were large patches of kinnikinnick pretty successfully. And then really focus on filling that annual niche with native annuals that are important for the butterflies. And I think I just have one more general comment here. Again, going back to the comment that not all fires are equal. We really must consider all aspects of the fire regime when we're discussing, evaluating fire effects on butterflies or really anything, because you could have very different impacts depending on the type of fire. And that we've seen that a lack of fire really can lead to a degradation of butterfly habitat over time. So we need to find that happy medium between annual burning and high intensity burning and no burning at all. So we can find something that both achieves those objectives for the butterfly habitat while protecting the butterflies themselves. And then finally, I want to mention that it's one of the suggestions and conclusions that I've read in a lot of the literature about fire effects on butterflies is that we need to just use other treatments like mowing, herbicide, and grazing. And I think those can be very effective at small scales and sometimes at large scales, but paired with different treatments. And so we need to consider the feasibility in terms of the time and the money, the resources that are needed to, for instance, mow across 800 acres, or herbicide twice a year across 1,000 acres, which is necessary to keep these invasive species at bay. Compare that and see how those can be used in conjunction with fire to decrease the fuel loading, for instance, so you have those lower severity burns. There may be opportunity, and we're investigating this now, the role of grazing in butterfly habitat management. That's been shown to be fairly effective down in California and in other areas of the Midwest. There's an opportunity here in Washington, I think, as well, to kind of pair conservation with working landscapes. Yeah?
What kind of animals would you graze?
Right now we're looking at cattle, but I think there's also discussion of horse and even pigs. I guess that wouldn't really be grazing.
Goats?
Goats are evil.
It wasn't exactly what I was going to say, but our concern with goats is that they would probably eat anything that's there, and we don't necessarily, we want them to be selective, and we know that the cattle and the horses would likely be more selective.
What about sheep?
Evil,
No.
range maggots.
I'll let you discuss that afterward. It's something that we're learning about and investigating now in terms of how that can impact prairie habitat, and if it could be used to either create or maintain prairie habitat. That's, I think that's a really valid question. But most likely it would be used in conjunction with some level of burning across the landscape. So with that, I'd like to thank a wide suite of people and organizations, and I'm happy to take questions and discuss if you guys are interested. Yeah.
So you said when the burning occurs, the Taylor's Checkerspot is underground.
Yes.
And you said you found that there was no impact of the burning on the main butterflies. So,
The main butterflies.
and I wrote that down, no impact on main butterfly species,
Significant species.
significant species.
They wouldn't be out during the burning.
I think, I'm not sure what I meant when I
Meant
said that, but
Overall impact, I think what she's saying is that you said something to the effect that you're monitoring the impacts, and so far you haven't observed, within your regime of burning, you haven't observed impacts on the main butterflies of concern.
okay, so we are not, if I can say that for Joint Base Lewis McChord, where it's burning every year, and there's like the healthiest population of Taylor's Checkerspot there. There's a lot of information on that system. On the areas that we have reintroduced Taylor's Checkerspot butterfly, we have not yet burned those areas that they exist.
So I'm just wondering about all the other butterflies, because they.
Oh, sure.
So, and they're all still coming back?
That's a good question. I mean, we have, there's not a regular and consistent monitoring effort for all of the butterflies. And so I can't say that for sure, but there's not a focus on evaluating specifically fire effects on those. We have seen, I know Cheryl Thimble did some work looking at different types of pollinators, looking at bees, and she did look at some of the blues, I think, and she found no impact. In fact, she found that sometimes because there were more resources post-burn, it was actually better. Like she saw an increase in the use, and I don't think she was actually looking at population levels, but just looking at the use and the activity of the burn areas.
I think the secret is small patches rather than burning the entire prairie.
Absolutely, and that doesn't happen.
That's your answer, because
So, yeah.
they will migrate from
Right.
one area to
They'll
another.
move.
They'll be-
And timing,
Yeah.
so burning small and timing it right so that you're not affecting, adults that are flying or larvae that are moving around on the surface.
I have a question. Cheryl and I did a survey on Johnson's Prairie,
Oh, great.
and we studied it every spring and summer month,
Mm-hmm.
once a month. And we found that the Puget Blue there is just doing just fine. It's you have lots of movement in there, and they're doing fine. But we did not see one Taylor's Checkerspot the entire time we were there.
Where is
So
it?
what I'm wondering, this is Johnson's Prairie,
Thank you.
which is over by Rainier, Washington. It's really remote from the fort. It's probably the
Right,
most remote
right.
one, isn't it? Anyway, I was wondering if you guys have made any strides forward with the Checkerspot in Johnson's Prairie, because that's a nice prairie.
Yeah, it is, and that's, do you know if there's a checker spot there? I don't think there are any checker spot there. I think it is a reintroduction site
Yeah.
down the line. It's
Well,
not
we
number
noticed we
one,
didn't
but
see a
it's
lot of
there.
food plant.
I'm sorry?
When we were doing the survey, I was also looking at the plants.
Right,
Should have had Stuart with me, and I would have been more thorough study of the plants. But anyway, we didn't notice a lot of food plants for the Taylor Checkerspot there.
right, so that's a problem. And that's been one of the primary areas of work in these prairies where that are slated for reintroduction is getting those oviposition and host plants in the ground. So a lot of the Castanea hispida, there's been some recent work looking at Castanea levicecta, golden paintbrush as a host plant, and it's very very encouraging. It looks like that they can actually host a nectar on golden paintbrush as well. And then the Plantago lanceolata, which is a non-native species, but which is
But
one.
that should be easy to grow.
It works. It's easy to grow and easy to outplant and easy to everything. And it's found on all of these prairies already. And so the goal is really to increase pretty dramatically those resources at those sites before the butterflies even are released.
I have another question too. I live over fairly close to the Purdy prison, and I noticed that they have a program there growing plants for you. I believe they're
Yep.
for your student. And what are they growing? Of
So-
course, I can't go in and look.
Right, yeah.
That
it's
will let
fun,
me through the
yeah.
wire.
Right.
But,
So
You can arrange that, Bob.
If I commit a crime, maybe they'll let me in.
yeah,
But
it's
anyway.
probably not worth it. So I can just tell you, you don't have to go that far. So they're actually growing plants and they're growing butterflies.
Oh, they're butterflies
Yeah,
too.
they're growing the Taylor Checkerspot butterflies. So it's the women's prison and Stafford Creek. There's I think one other men's prison that are growing native prairie plants, and hundreds of thousands of plants.
I saw the greenhouses.
Yeah,
They've got a big
and
production.
yes, it's huge. They're growing more than anyone, and I don't know, maybe 40 to 50 different species. And 2 years ago, Department of Defense funded the production of a greenhouse, building of a greenhouse at Purdy Creek for the captive rearing of Taylor's Checkerspot butterflies. And so the women there are actually working on producing these butterflies. They tested first, I think, with cabbage white. I'm not sure what they tested on, but a more common species just to get the methods down.
Painted ladies.
I'm sorry?
Painted ladies.
Oh, they did it with painted ladies. Okay. And it worked really well. And the butterflies that are coming out of their production facilities are look great. They are very healthy and are the main source, along with Oregon Zoo, of captive reared animals that we're putting out on our prairies. And so that is part of the Sustainability in Prisons project that is through Evergreen State College and Department of Corrections, Washington Department of Corrections. A very inspiring and successful program that is really working to kind of pair conservation with incarcerated individuals to build skills and interest and reduce recidivism. So there's going to be fewer people going back to jail once they get out. And they'll have some real world conservation skills. So I highly encourage you to check it out. Yeah, you had a hand up earlier.
Yeah, thinking again about some of the other species of butterflies, many of them have different techniques for lifting. Taylor Checkerspot probably a little bit below the ground surface. Probably most of them like peanuts will be down in the ground somewhere. But you get pierrots, you get swallowtails that are going to be hanging pupae that are well above the ground surface. I suspect they must be pretty detrimentally affected by that.
Yeah, if they are hanging out above ground in the late fall and mid to late fall, then they could be detrimentally affected, absolutely. And so I think, again, the key there is having those smaller patches so there are refugia for recolonization. And identifying where those are. I mean, if it's possible to survey before the burn and identify where those are, there may be the possibility to do exclusions to protect those areas. Yeah.
Your Anna swallowtail is pretty common in the prairies, and that's a lomation feeder, and I've reared them there before from the prairies. And but you're going to see the larvae in June, and they're going to pupate, and they're going to be hatching probably into July and August. So my question would be, is I'm not exactly sure, maybe David would know, where they're laying the eggs. If they're laying the eggs close to the ground, maybe that would save them.
Yeah.
But I'm worried about it because if you're going to burn in the fall, you're not going to affect the butterfly or the larva. They're done with their life cycle, so they'd be in the egg stage. But
Annas will lay their eggs right on the lomation.
pardon?
The annas will lay their eggs right on the
Right on the plant.
Right on
Now,
the
that's why I wasn't sure.
Do you have good support for the
plants are
idea that there's two
senesced
broods of anise
by
in
that
it?
time. The plants are senesced in July, August.
Right.
So I'm wondering if they're just hanging out on the senesced litter, or if the eggs are they just stick to that. I'm not sure.
Yeah, David says that they laid it right on the
They
plant.
lay right
so-
on the lomation, and
Hey,
that's
Bob,
where they
are
stay.
there two broods of the anise in the prairies? I think
Yeah.
there's only one brood.
Oh, I've raised them, and so I know.
Well, you raise them in the lab, then they'll emerge.
Well,
Are they in the prairies?
I haven't actually
That's,
noticed.
yeah, we don't have any records of a single brood from the prairies. So
But
maybe that's
if
all.
you rear them, they'll come out in July.
Sure.
I was watching Anna swallowtails ovipositor just a few days ago on lomation.
Oh, great. Okay.
They're mid-plant, I believe, so.
Yeah.
I think part of what you're doing though is you're always having to target species that are endangered, whether that's butterflies, birds, plants, or whatever it is. So if you have Taylor's and that's the endangered one, you're kind of making that case for that one species. And in effect, you're just having to say, we'll sacrifice some other species that are going to be hurt by this because they're abundant. They're all over the place in, say, western Washington. And whether, it sounds like it would be a nightmare to figure out what you have to figure out, which is, there are plants, there are butterflies, there are birds, there are mammals, there are all these things. How can you make that puzzle work so that you can say, we're not killing the plant, we're trying to say, well, we're saving butterflies?
Yeah. No, that's a really valid question and one that the managers are really challenged with. And part of the solution to that is one, that the habitat needs for the Taylor Checkerspot butterfly do support a wide variety of other species. And so it's kind of an umbrella species in that sense that, you know, if we restore habitat for this species, it's also maintaining and restoring habitat for several other invertebrates and other species in general. However, there are some other species like the streaked horned lark, which was also just listed as threatened, that really prefers really wide, open, very sparsely vegetated areas at most airports. That's not going to be very attractive to the Taylor Checkerspot butterfly. And so we have to prioritize different areas for these different suites of species and the different kind of functional groups. So, so it is something where we have to think, okay, if this, what can this landscape provide? And what should the priority be for restoration and habitat maintenance here versus over here, where we should have a different starting point, and maybe there's a different, maybe those species already exist there, so we want to maintain them. So there is a little bit of a puzzle to figure out across the entire conservation landscape who should be fitting where. So yeah, because unfortunately, most of these species are not going to, at least the ones that have been listed, may not overlap everywhere they exist. I mean, there's going to be patches where they do and patches where they don't.
But in the long run, I think you're going to be ahead because you're not burning the entire prairie. And
Right.
so the parts you do burn, yes, you may lose like the amp swallowtail in that group, but maybe the next year or two, you're going to get a lot more formation growing
yeah.
up there than that anyway. And so they're going to come back in
They're all going to
abundance.
move over there, and then
So
over the other
yeah,
side.
you're going to move from one place to another. So you're, as long as you don't burn the whole prairie, I think you're fine. That's a sound practice, I would think.
Well, after looking at this for a little over 4 decades, I can say that it's a lot more promising now than it was like 15 years ago when we were informed that a prairie was going to be burnt because they had the funds to do so.
Right.
And there was like a commitment to that, you know, if you don't spend your money, then you don't get any more, right?
Yeah.
That was, you know, pretty scary for me. We just discovered this butterfly, and we went in, you know, like, wait, oh no, we're going to burn it because we got the money to do so.
Right.
But right now, it's a lot better than that. So
Oh yeah.
I'm very comforted to hear from you.
A lot more strategy, a lot more sophistication in terms of the techniques that we can use and are using, and sometimes the decision is not to burn. In fact, that has been the decision in a lot of cases, but for better or worse. But I think that there's not just the decision not to burn, but there's the decision to, you know, pick the areas where we should be burning and let some of them be.
Well, we've already developed some very advanced techniques for doing that too.
15 years ago, he told me I should just watch them go extinct.
Yep.
Well, that's what I do.
That's what it probably looked like.
I'm
so,
monitoring the extinction of Washington butterflies.
Yeah, that's great. That's really depressing. Yeah. But I think we have a few success stories here that are really, I don't know, I think provide some hope that there may be the opportunity to recover some of these species using a wide suite of techniques and across, you know, a pretty broad landscape, involving a lot of different people and organizations and opportunities. So,
In the 70s, we saw abundance of Taylor's Checkerspot in the Bethel High School playfields.
Oh,
In the
yeah.
70s.
Wow.
They used to be all over Spanaway. We had them in our yard.
Wow.
That was in the 70s.
Yeah.
Things have
Wow,
changed.
what a change. Yeah.
Okay, well, thank you very much, Sarah.
Thank you.
That was very